here with the, I just turned my phone. Good afternoon, everyone. Glad to see you all here. We'd like to welcome everyone in the audience, the participants that are online. We welcome you to the Waste Management Committee meeting. I'm Earl Shepard, the Waste Management Chair.
Now attending.
This committee is comprised of myself, David Hoyle, Berlene Ennis, Mr. John McMichael, Louis Walters, Susan Corbett, and Jenny Jones as Vice Chair. The committee's purpose is this committee reviews the management, treatment, storage, and disposition of radioactive waste, including transuranic waste, low-level waste, mixed low-level waste, and radioactive liquid waste, and provides advice and recommendations to DOE on these activities. Principal goals of the committee are to see a trend in reduction in the risk to public, workers, and the environment posed by these wastes, and integrated and comprehensive systems approach used in weighing SRS waste management and disposition options. We have no pending recommendations at this time, but we are working on some new items. Our next committee meeting will be October 6th, back here at the New Ellington Community Center, from 4:30 p.m. to 6:20, New Ellington facility where we are now. Presentation tonight is Effluent Treatment Facility Overview by Doug Bumgarner from SRR. And at this point, we'll have a point of contact status update by Mr. Jim Polk.
All right, thanks, Earl. If this is good enough, I don't want to talk to anybody's back too much, but I'll just go from here. You got a pretty good update last week at the full committee meeting, so I'll just kind of pick up some of the highlights, and certainly if there are any questions, I can address those. Or, as I've said, some of the smarter people in the audience can address those. But for tank closure specifically, tank 16, we're now up to about 89% complete. Pretty much with any job, as you get to that last 10%, this is when we start filling cooling coils and some of the equipment and stuff like that. So it'll be a little bit slow going here the rest of the way, but we're still well ahead of schedule to finish by September 30th. Should finish in about a month or so. So that's been looking very good in that whole process. Biggest issue there has been the heat, but we've been able to work around that. And as you can imagine how that is out in the tank farm, most of you have been there. The tank 12, we have a commitment, the revised commitment was to finish physical ready to grout by 9/30, and then with the grouting to fall next year. So we're well on track for that as well. So physical completion is looking real good for 9/30. Again, there'll just be a few little connections we have to make, but they have to wait the last 2 weeks ready before you start grouting. So tank 12 is good as well. The other piece of the dispute resolution process that came out was the cesium removal expression of interest. As we reported last time, we did complete the expression of interest June 1st. We had Industry Day, brought in some of those folks. Got a lot of good input, and so now we're evaluating that as far as where we go from here. We had also released a draft RFP in that request for proposal in that process, and so we got a lot of good input from that as well. So we're taking that input, looking at drafting up that draft RFP, and then see if we're going to go out for an actual request for proposal. Again, a lot of factors there, including funding and the like. So we're weighing all those things right now to see if we proceed. But if we do, I expect that to occur in the very near term. From a facility perspective, DWPF, the Defense Waste Processing Facility, is down. We've resolved our primary mercury issues, but in resolution of that process, we identified another mechanism which is of a little bit of issue to us. So again, in the prudence of safety and caution, we're shut down until we complete that analysis. The contractor has completed that analysis. They've provided us their documentation of that. So now DOE is now in the process of reviewing that. Probably be about a month or so till we complete complete that. And then it'll be a timing case of, do we actually start the defense waste processing facility up in September or wait until October? There's a site outage scheduled for steam outage. So, again, it's what's best. You know, you try to come up for a week or something like that and then go right back down. So we're looking at that. In the meantime, we're doing a lot of good maintenance work, things that we would have done in the outage in October, we're bringing up to now. So it's not wasted time. There's a lot of good activity going on in the meantime. Again, from a raw number count, we're going to be at about 90 canisters for the year, most likely. We had a target of 156, but we're doing the right thing by taking a step back and making sure we have everything the way it ought to be before we go on. The ARP-MCU facility, this is our actinide and cesium removal process. That facility is currently shut down. Again, if you remember our gear charts, which we tried to do very well in that demonstration, in those presentations, when one of those gears locks up on us, the rest of them start locking up behind it, and that's where we are. Since we can't run DWPF, we have no place to send the product from the ARP-MCU, so we're in an outage there. But again, we're taking advantage of that by bringing in some of the outage work that we had scheduled for later on in the year, some of the maintenance work, and doing that now. So we're a few weeks away from completing that, and then we'll be sitting waiting on DWPF startup to continue that process. Earlier in the year, we have had a really good runs through that facility, processed about 750,000 gallons for the year. So that's doing pretty good. Some of the challenges we've had. SDU 6, our 32 million gallon tank that we're building, we're over 50% on that. Pretty much completing a lot of the final tank preparation work that we have going on there. That'll then be followed by some leak testing, checking, hopefully everything works out there. And again, that's only part of the job. You know, you see a big tank out there at that point in time and you think you're good. You have a lot of work still to do. So there's still a lot of electrical work, a lot of physical piping that has to tie into the system. So we're still about a year away from completion of that overall project, but making great progress on it. And again, so we passed the 50% mark on that job as well. Finally, I guess the Saltstone facility, we've had a good run there up till about 3 weeks ago, had a little process upset and had a damaged pump, so we have to go in and fix that pump. We've completed those repairs. The system is ready to go. Should be doing checkouts here over the next day or two and get that back up and running. We actually ran about 350,000 gallons or so far for the year. And as you know, once that's up and running, it's usually 30 or 40,000 gallons a day kind of process. So we really can make up a lot of time at that facility. And again, just from outside my program specific, but over to the project side, salt waste processing facility now reporting themselves about 86% complete. Targeting, as you know, they have construction complete September 2016. They're running somewhere about 6 months ahead of that schedule. So that's a big goal for the project side of the house. And on my side of the house, the operations side, a big part of my mission is to tie that facility up, get the feed ready for it and the like. So I've probably got $50 million worth of work just on my side to tie that facility in. So big focus area on my part. That's where we are program-wise.
Earl Shepherd, Cam. Jim, when you start doing your leak testing on that 32 million gallon tank, that means we're going to fill that up to capacity with potable water?
We're going to fill it up. We've punched about 3 wells down behind that facility. So those 3 wells will fill that SDU 6, and we're assured we will have a leak-tight vessel by the time we're all said and done.
And that gets discharged back into your sanitary sewer system, so you have some flow.
And it won't be the sanitary sewer necessarily, but you know, we do have the regular discharge for that back into the groundwater, if you will, or surface water.
Yeah, it's massive because in the wastewater industry, we have Crom tanks that we use, and we fill them, and it takes quite some time, and then it takes quite some time for it to sit there and monitor, and you monitor for leaks, and you may see one little dribble, and you got to bring it all the way down, and then go back up.
Yeah, we've been through that process. We had the 3 million gallon tanks, the SDUs 2, 3, and 5 that we built. We did have some indications on those tanks, so yeah, I'm right with you. We usually put a little fluorescent material in there and go out in the middle of the night and check it, see if if we have any, indications of issues. And, yeah, we've gone through that process of draining and repairing and moving on. So, hopefully with this one, we're gonna be in good shape.
Thank you.
Good. Deb.
Jim, can you elaborate a little on the twist that you've gotten in the evaluation of the mercury issue that you're now taking a look at?
The twist you mean with regard to the Anyfoam in DWPF?
I don't know, I'm asking.
Yeah, if you're referring to what I just spoken to earlier, in the evaluation for mercury in the system, throughout the system that we've done, the lab has been doing further tests on some of the other aspects of DWPF, the whole process. What they found was that this antifoam material, for people who aren't familiar with it, it's got all kinds of chemistry names, so don't ask me those, but the process, just as if you were boiling vegetables on the stove and you get bubble up, we put a process in there to avoid that, to keep that minimized. What we found, and that's been something that's been going on for years, the lab identified was that material, that antifoam, actually under certain conditions will break down into a variety of gases, some of which are flammable. So we now, due diligence, have to go back and say, okay, now, how much is that? What restrictions might we need to put in place, measures that we have to put in place? So that analysis is going on now. And that's really going to be done in two phases. One is a near-term phase that says, for the known material I'm currently processing, am I okay? And then a longer-term phase that says, for any material, do I change that antifoam? Do I change some of the parameters? So that's the analysis we're going through right now. The contractor believes we've reached a resolution on the near-term stuff, and that's what they've delivered to us, and that's what we're analyzing now.
One more question. Can you tell me a little more about the upset at Saltstone?
Saltstone's a grout facility. So what happened there was that there was a blockage that had occurred in the system. And very simply, we have a mixer where the dry feed material mixes with the salt solution, goes into a hopper, gets pulled out by a pump. In that interface between the grout hopper and the pump, a blockage occurred. We're not exactly sure why that was. We also damaged the pump at the same time. So we don't know whether, and this is something that's ongoing as we speak, so if there's anything more, a guy or somebody can jump in. But what we don't know yet was, did the blockage damage the pump, or did the pump fail, cause the blockage? And so what we've done is cleaned out the system, replaced the pump, and we've got everything buttoned back up, ready to go. So that's where we are, continuing some analysis on that piece of equipment and that process itself. But again, from a system perspective, things are back up and buttoned up, ready to go.
Did that cause the piping from the pump to the vault to be rocked up?
No, what we were able to do was it was only isolated right in that lower section of the hopper and leading into the pump. Because we've incorporated a number of systems where we can actually flush downstream and upstream of that, of each of those components now. So yeah, everything from the pump down was fine. You probably remember some of the experience we had where we did block up some lines in the past, but some of the lessons learned was to install a flush mechanism to be able to get that stuff out of there as quick as we can. And all that works fine.
Great.
Have any of the other sites had similar issues with the anti-foam that you could learn from, or is it sort of unique at this point?
And nobody else is out there vitrifying.
No,
So,
just you?
yeah. So again, we rely heavily. Now, there are other research facilities. For instance, the lab has its mock-ups of our systems. Also, at Catholic University, they have mock-ups of our systems as well. So, we're relying heavily on some of the laboratories to help us out through this. Okay.
Yeah. John McMichael, Cap. Going back to Earl's question about testing, just for our edification, how is it certified what you do all the testing? Is it internal, in-house, or is it external certification?
They're set up to, and I can't remember the name of the standards. I don't know if anybody here can help me with those. But it's an industry standard where basically you're checking for wetness on the surface of the tank, okay? And so it's like I said, standard industry measure, if you will. And so our guys are trained to do that same check. And that's, the contractor's responsible for that. I've got people in the field as well who are overseeing that work stuff.
Corbett. So how did you solve the mercury problem?
Well, it's
It's
not all solved yet, okay? But as we went back through the systems, we kind of did a systematic walk back through the liquid waste program. If you think about it, we identified what really got us going was the tank 50 issue.
Yeah.
Identified, okay? We went back and did the environmental measurements with T-Cliff review that said we were okay there, that the material we were sending over to the salt stone facility was going to meet all our environmental regs and requirements. And then worked our way back to see if we can identify where the mercury, this form of mercury, is being generated. We know mercury's in the system, but where is the methyl form of it being generated? And then we're basically clearing the system as we go backwards. We haven't found the smoking gun yet there, but in that process, we're able to say we can continue processing without any environmental impacts at Saltstone. Then we went back and we cleared MCU. We went back and we were clearing DWTF. So again, that's the near-term fix, and also looking at, similar to what I said on the anti-foam, we know what we're processing now, and we can assess that. Now, there'll be a longer-term assessment that says, how do we actually get the mercury out of the system? And that's the part they've set up a expert panel on, and I believe it's October when they'll be giving us the results of that assessment. So again, a short-term answer, we looked at what we have and confirmed we can process. Then we need a longer-term answer, how do we actually start removing it on a more significant basis?
Okay, one other question. I'm still trying to understand the tank closure process. So you mentioned you're getting down to the piping, which is the bottom. Is that all left in the tank when you close it? The piping's left there, or is that removed?
Yeah, well, what we're referring to in piping are the cooling coils.
The cooling coil.
These tanks have 3 miles or so worth of 2-inch cooling coils throughout. So yeah, that's left behind, but in order to ensure that we don't have a flow path through there, we actually grout the inside of those cooling coils as well. So if you think about it, we do the bulk filling of the tank, and then we go back in and actually go fill those 3 to 4 miles worth of piping. But again, a special formulated grout that'll flow easier and be able to be pushed through that system.
I'm assuming those pipes are very highly radioactive, obviously. What is the main or the top?
Name it, we got the soup in there.
Everything is in there, right?
But
Okay.
again, it's gone through the whole performance assessment process. So we've removed it to the extent we can, which is usually 99+%. We've done the analysis that says, from a performance analysis perspective, what is the projected dose over time? It's probably 3 or 4 millirems at most to the outside world. And then once we get that, the state approves that closure module, and then we proceed with closure.
I'm assuming all these tanks are somewhat different. They're not all exactly the same, right? And they all had different kinds of waste in them, different mixtures, right?
And that's why we sample each one and do the analysis on each tank before closure.
Is there ever an estimate done on the amount of curies that are actually left in the grout, that will be in the grout? Is there a curie estimate for each tank?
Yeah, there is. I don't have it.
A place where I can access that
Yeah,
information?
as a matter of fact, if when you look at our briefing I do, and several of us have done it now from the overall system flow chart, we have an estimate on there, and I won't quote a number because I don't know it off the top of my head, but it's much less than 1% of the total curie inventory is left behind.
Is there some place that I can actually, is there like?
Well, performance,
a
yeah, and I'll check. I think our performance assessment's on the web. If not, that would be the source.
Okay. I'd like to take a look at that.
All right.
Thank you for your report. Now, we'll be moving on to the effluent process system overview, presentation by Philip Baumgartner from Savannah River Remediation.
Good afternoon. Thanks for having me here. I'm Doug Baumgartner. I'm the Deputy Facility Manager for the tank farms and the effluent treatment facility. I'm just really going to cover an overview of how the effluent treatment facility process works. And so if you go to the you guys have probably all seen this before. Here's all of the liquid waste facilities. F Tank Farm, H Tank Farm, the Canyon processes, DWCS Saltstone. The effluent treatment facility is kind of down in the corner of H Tank Farm. That's where the processing plant is. In addition to that, there are basins that collect stormwater, both in H area and F area, as well as basins that would collect cooling water from the canyon systems. So it's a little bit hard to read, but so the stormwater that's collected, there's about 170 acres of facilities, so that stormwater is all collected, goes through the basins. And you just see that there's different parts of ETF that are spread out, you know, across the whole width of our facilities and liquid waste. So. And from a overall SRS process point of view, as you guys all know, canyon materials came in through the tanks, and then all through the rest of our processing facility. These two processes really that then get material into the effluent treatment facility. One is that the waste tanks goes through our evaporators, which is just kind of a big tea kettle. The liquid stream, the overhead stream, it's really low-level waste. It's decontaminated through the evaporator process. Those overheads go to the effluent treatment facility. And then there are similar evaporators within the canyon system, as well as some other waste from the outside facilities of the canyons that get routed to ETF. And then there's a couple smaller streams that are lab waste from both the lab and C area as well as SRNL. There's a little tiny bit of waste that comes from the tritium facility. But overall, all of the waste that's coming into the effluent treatment facility is low-level waste. It's low activity. Most of it's been treated before. A lot of that waste, like I said, is just kind of stormwater that we'll monitor before it gets released. And I have an acronym list on the back sheet of the slide if you guys are looking for that. The effluent treatment facility was built in the mid to late 80s, started up in 1989. Like I said, it's treating low-level radioactive waste. Typically, it'll process at about 165 gallons per minute, so that ends up being over 200,000 gallons a day. So we'll walk through the flow sheet and see how that works. And then the facility is permitted through the NPDES, the National Pollution Discharge Elimination System. That one might not be on the acronym list. It's all the limits that we work to meet relate back to that permitting. Overall, I'll go through each step of these on subsequent slides, but this just gives you an overall view of all the steps in the process that we use to take that low-level waste, get it clean enough to be able to discharge, and then there's a stream, so the contaminants that we've taken out in the process come back through the facility, back into the tank farm, into tank 50, which we talked about a minute ago. That then feeds into Saltstone. So, kind of stepping through each of the different facilities. As I mentioned on that aerial view of the tank farms, in each area, in both F and H area, there are basins. Really, there's two sets of basins. There's a cooling water basin. Again, that would receive material from the canyons. So the canyon has a cooling water system that gets monitored. As it gets discharged, that comes into our cooling water basins. And We then, will monitor that again. Normally that should not be a contaminated stream. If it was contaminated, we would route that through our process. Assuming it's not contaminated, that then goes on to our stormwater retention basins. Stormwater basins, in, H area hold about, 2.7 million gallons. The, basins in F area are a little bigger. They're about a 5 million gallon, set of basins for the cooling water. And then the stormwater retention basins, again, from that 170 acres of facilities we've got, that rainwater is collected. It gets routed to these retention basins. Basin in H area is about 8 million gallon capacity. In F area is about an 11 million gallon capacity. That gives us an opportunity to check that water for contamination. And typically it's not contaminated. It gets released directly to the creek. If it was contaminated, we can treat that through the treatment process. All waste that comes in from the other facilities, so overheads from the waste evaporators, get routed into two 450,000 gallon wastewater receipt tanks. We operate the facility as a batch process, so we collect enough water that we can run for a few days at a time. So again, we can typically process 200,000 gallons a day. We'll typically run kind of every other weekend sort of thing. And that allows us to build up enough inventory that we get the process lined out, run, and then shut down. And in between periods where we're operating within the facility. So the first step is really just to receive that low-level waste into these receipt tanks. We'll then sample the material. That allows us to evaluate what the chemistry is. And then based on the chemistry of the water that's there, we'll do chemical adjustments that allow it to be processed. So some of that is to line out the pH so that it can pass through all the resins like it should. Some of it is to then precipitate some solids so it'll be easier for it to filter out. So this is kind of like pool chemistry kind of thing. You want to try to get clear water. So there's some chemicals that you add that'll help stuff to precipitate out. So when you run it through the filter, it'll collect those things. So that's the first step in the process. Once we've done the chemical adjustment, then there's a filtration process that will remove those suspended solids. And this is sort of no different than a filter you might put in your coffee maker. It's just there, you have to liquid through it. If you have a bunch of solids in that liquid stream, that filter would catch it. So the clear material that's been filtered goes on to the next step in the process. The solids that you collect ultimately come back into the evaporator process. Once you've filtered, once you've done that first filtering step, get the suspended solids out, you really go through each step is a little bit more solids removal. So the next step is organic removal. In this case, organic is material like tributyl phosphate. It's a stream that has carbon in it, basically. But it's one of the reasons that step of the process was designed was in the Canyon process. They use tributyl phosphate when they organic make that process run. So you've got an organic removal step, and it's an activated carbon bed. I kind of think of that like a burrito water filter, that sort of thing. And then you've got a mercury removal system, which is an ion exchange media. So again, it's another thing trapping that particular mercury species. Those columns run, and through the process, we do different steps to clean those processes, clean those resins, filters, so we can continue to use it. Ultimately, when that resin So once you've gone through that, you get on to the next process, which is reverse osmosis. And reverse osmosis is a process that removes dissolved solids. So this is, you've got a really tight filter resin, filter media. It will allow the clean water to pass through, but it won't allow the contaminants to pass through. So this is kind of similar to like Gore-Tex, if you think about it. So Gore-Tex will let vapor come out of it, but it won't let water go through it. It's kind of the same concept as that. You've got a media that's going to let just the pure water pass through it. So it's pumping through at a pretty high pressure to make that happen. But again, just kind of fundamentally it's another filtration process. So again, the clean water moves forward in the process. The contaminated liquid then goes back into the evaporators. The clean water goes on to the next step. It's more ion exchange columns, so there's ion exchange media that's designed specifically to remove radioactive contaminants, as well as the set columns that are designed to remove heavy metals. That's the last step in the process for the clean water. That clean water then goes to the treated water tanks. There's 3 treated water tanks, as you can see in the photo. Each of those are about 160,000 gallon tanks, and typically the working volume. So when you account for how the different level limits for low level and high level, typically they're about 120,000 gallon capacity for working volume. So the treated water comes into these tanks. That gives us an opportunity to have storage space so that we can then sample that material, that clean water, verify it's meeting the discharge limit. Once we've demonstrated it meets the discharge limit, we'll then discharge it. If we got sample results that did not meet the limit, we then recycle that water back into the process. Going backwards in the process, there were a couple steps where the solids and other contaminants went into an evaporator system. Again, the evaporators at ECF are just big tea kettle kind of things. The contaminants with a liquid stream will come in there. There's some cleaning solutions as we maintain our process that go in there. We evaporate it to remove liquid. So take out less space in salt soluble. And the liquid that's boiled off, the water that comes out of the kettle, goes back into the process, gets treated. Ultimately, as it gets treated, it will ultimately get discharged. The concentrated material where the contaminants are, it's goes 50, and then we make salt. The last slide is just a little overall, since 1989, we've processed about 280 million gallons of water. Again, although we would typically see it meet drinking water standards, that's not the requirement. The requirement is the NPCS permit. Each year, we process nominally 5 to 10 million gallons of water through the plant. There are other streams that go through the basin, the retention basin, the stormwater basin, where we might typically see 50 million gallons a year go through those basins, get monitored, and discharged without needing to be treated. So, like I was talking really fast. Any questions?
Yes.
Okay.
I have several questions because this is my realm.
You know more about it.
Well, is the effluent released on site, like sprayed back on like pine trees or something, or like a
Yeah, you go back to that aerial at the very beginning. I don't know that this will actually show exactly what I want to show you. Okay, so you really can't see. There are, you may be able to see here, there's creeks that run through the site. So there's the Upper Three Runs Creek and there's 4 Mile Creek. So what actually happens is the treated water tanks are over here. There is a pipeline from the treated water tanks that really runs basically along this road, makes a turn up the wall, and it goes down to the creek itself. So the discharge from the plant is actually into the creek. There's some mixers in the creek to help distribute that out to the rest of the water. It gets discharged to the creek, and that's the
and we talked about solid waste disposal. So is the waste from the process, is that, does that become solid waste by gravity thickener, vacuum press, or screw press? How do we compact the sludge?
Yeah, it's probably a little different than, let me say one more thing about the discharge to the creek. So we sample at the treated water tank, so we know it's good before we discharge to the creek. And there's additional sampling that's done at the creek. So there's a couple places where we're checking, make sure we're meeting. The material that becomes solid waste is really only the spent resin. So the actual process material that comes through, everything that's come through the high-level waste process itself is a liquid stream. The solids that get filtered off and sent into the evaporator, all that material ultimately goes into salt zone. The ion exchange columns will regenerate those columns. Ultimately, at some point in time, they will regenerate. And at that point, if we were to unload a column, so if you just, I use the example, so the Brita water filter. You got to think about that one, kind of activating purposes. So if you're looking inside of one of those filters, and then you've got a fresh one, you can see a bunch of charcoal kind of stuff coming up. So ultimately, that charcoal kind of material, that resin, won't be able to hold any more of what it's meant to collect. And at that point, we would need to empty that column out. We'd empty it out into containers that would allow that material to then be disposed of as solid waste.
Okay.
So it's really just the resin pieces that are disposed of as solid waste. The material that's actually come from the process itself, it's really pretty clean water to start out with. Most of it's been through an evaporator, so it's steam that's come off. There's not a lot of solid material that actually accumulates from the waste that's treated at the plant itself.
Okay, I have 2 last questions. On the pH scale, where does that effluent lie? Is it like acidic, neutral, basic?
When it comes into the plant, yeah. So typically, there's a couple different strains, a couple different things that come in. So typically, the rainwater comes in; it's a little bit acidic. The material that comes in from the evaporators in the tank farm, typically that's a little bit caustic pH. So it's a pH above 7. All of the tank farm is maintained at a high pH to help protect the tanks. And so as you boil that material in the evaporator, the overhead, the steam that's generated there, picks up a little bit of that caustic. And so typically that material that's coming in is maybe a pH of 9, 10 as it's brought into the plant. So that's one of the things that when we sample the treated water tank, the collection tanks, the tanks at the beginning of the process, depending on how much of the different streams that have come in from different facilities, we'll have different pHs. So that's one of the reasons why each time we'll sample those tanks and make sure we know exactly what it looks like and make the right chemistry adjustment.
Okay. And my last question on slide number 12, exactly what are we seeing at the bottom of the tank? Because it looks like some kind of bright light, or is that just a flash on a plate there?
Actually, just a mixed That's a nameplate, and it's just a strange reflection. I don't, yeah, there's nothing glowing with that.
Okay.
Thank you.
David Hoyle, Cab. You mentioned that you have organic and mercury removal. I don't suppose that the mercury is passed on to the evaporators again and recycled through the system. Do you remove the mercury?
Yeah, so typically that mercury is removed in the column. So as we monitor the process, so we've done things where we've looked at the amount of mercury coming into the ETF facility from the high-level waste evaporators, which there is some that comes in that way. And then those mercury removal columns are very effective. What we see when we sample, there's a hold tank for the concentrated material from the ETF evaporators that we can sample before we send it to tank 50. When we sampled that for mercury, it's been very low concentration. It's been at the detection limit sort of number. So we know, as Jim mentioned, we've gone backwards, looking at where did mercury come from. One thing that we double checked is what's really going on in ETF. And based on that, and we've got a pretty good basis of samples. There's a lot of samples that we take in the ETF process because each time we bring waste in, it's a little bit different just depending on what's coming in. So we've done a lot of sampling over the life of ETF, and that's really demonstrated that mercury removal in ETF is efficient, and what's coming back to the tank farm from there is a very small concentration.
So what happens to the mercury removal?
And ultimately, as that mercury collects on resins, there's a couple things that would could bring it back into the process, but typically, ultimately, you get to the point where that would get disposed of with solid waste as you dispose of that resin.
I see. On page 7 of your presentation, it's a photo of one of the basins. Are both the F&H basins lined?
Yeah, all of the basins have a liner. I think all the liners are polyethylene. All of the basins have a liner. We have in the past replaced liners in the basins as we've seen damage to them.
Do you monitor leakage beneath the basins?
There's probably not really a dedicated monitoring system, but there are wells around the basins that you get an indication of leakage. There's some, as we fill the basins, just like everything else, we're monitoring level. It's probably a little bit harder to monitor basin level being outside. You've got some different things going on, but it's part of our normal monitoring process. We monitor the basin levels. We monitor areas around the basin.
And have the basins ever been overtopped or overflowed?
Not that I know of. Typically, like I said, there are a couple different sizes. Normally, our action limit for when we sample and pump the basins are when they're at sort of 25–30% capacity. So we'll normally maintain those at very low levels, just on the case that we had a really horrendous rainstorm or something like that. So normally they're maintained at a very low level to minimize the chance that you get into some event where they would overflow. I'm trying to think of sort of the highest level that we've been to. I can't think of any time that we've overflowed it. Like I said, our procedures are all set up to take action to shut down influence at a pretty low level.
One last question. Can you give me an example or an idea of what your MPDS discharge limits are specifically?
I'm going to have to phone a friend, I don't have a, I've got a couple of smart environmental guys in the audience, but I don't have it.
The metals are in the part per million range, 50 parts per million. pH is 6, 8.5. Not sure I'll handle the rest of it.
Any radiological limits?
David, what was the acronym? ND?
NPDES, that stands, there are none, in the NPDES permit, he said. NPDES stands for National Pollutant Discharge Elimination System.
There are no radioactive releases, or there are no limits?
Well, it's kind of a matter of how the facility's permitted. So the NPDES covers the chemical contaminants.
This doesn't cover radioactive releases.
That in and of itself doesn't cover radioactive.
So where do we find out what the limits are that you set up here for
Yeah,
radiological?
so within the DOE guidance for discharge, there are limits for radioactive discharge. So it's not that there's no limits, it's just that the limits are regulated through different.
Thank you.
So the tri-butyl phosphate, I'm assuming that that's coming from the canyon reprocessing, they use that to strip out uranium and plutonium and stuff, right?
Yes, I can't really speak to the canyon process, but yeah, historically that's been used as part of the canyon process.
So where does that end up? Where does that eventually end up?
Again,
As an organic material, so where does that go? It just goes into the solid landfill or solid waste?
Yeah, so again, that's material that would get collected on the resin, and ultimately, as you dispose of that resin, the organic is what's on, disposed of.
Thank you, Doug. Yeah. Thank you, great, for that great. At this point, we have, committee discussion. Is there anything that we need to discuss around the table from the cab members? Yes, Mr. Williams.
Well, I think we need to stay on top of, the outcome of this, mercury issue. I think, at some future date, we should request a briefing from DOE or the contractor on exactly how the whole issue, played out and how it was resolved. And, I'm a little curious as to what the mercury limit actually is, for saltstone, whether it's the TCLP or whether it's, the RCRA
Now
limit for
departing.
vitrified waste in RCRA. And so I think we need to get more information on the mercury issue as time goes on.
Can we work on that, Jim, please, in the near future?
Yeah, and I think, I believe Rich Edwards was here and kind of gave a presentation early on, about 2 months ago or 4 months ago maybe. So, yeah, we just make it a follow-on to the results, and I guess I would, recommend linking that into this, expert panel review when that comes out in October, so that way you can kind of get the whole story at one time.
Yeah, sounds good.
Thank you. Thank you. Ms. Tennessee.
The NPDES does not really deal with radiological releases into the water. I would like to get a sense of what are the DOE guidelines for really limits, discharge limits. I'd like to know what those are, where we can find those. Maybe we can have a presentation on sources that are being released and what that specific point, what is the limit there, or the amount allowed. I'd like to know discharge limits set by the DOE.
Yeah.
Down?
One other question I forgot. So the evaporators, do they just evaporate air, water? Is there anything else that is evaporated here?
But-
I'm sorry, I meant to ask this.
Well, that's okay. I mean, that's your byproduct, if you will. That's what comes off in the overhead, is water, and then the rest of whatever contaminant material is in there is what's captured on the off jet.
roundtable. Do we have anybody signed up for public comment? Because we're at that time. Public comment?
I don't think so.
Do we have any public?
Wow. Well, we have none. This concludes our meeting for the Waste Management Committee. Thank you all for coming, and we will see you next month at the full board meeting. Thank you.
Okay, it is 6:30. Powell, I am Chair of the Nuclear Materials Committee. Everybody, welcome to New Ellington. On my committee are Jenny Jones, Andrew Bush, Louis Chavez, Don Gillis, David Hoyle, Daniel Kaminsky, and Chris Tremors. We have no open recommendations.
We gotta fix that.
We gotta do something about that. We have no pending recommendations. And that's about the extent of it at this point in time. Maxine Maxted is going to give us a form contact status update, and Maxine will also be giving us our presentation today for the update on the H area operation.
You're gonna be sick of hearing me talk tonight, sorry.
No.
So is there anyone online or signed in? Okay. Not a lot has changed in a week since Tony gave you the agency update, but we do have a couple of things. So a lot of it's gonna sound very similar, but there are a couple of new things. H Canyon is continuing with readiness assessment for the various stages of processing the spent nuclear fuel. These stages allow for the purification and separation of the uranium and fission products, and then the other waste materials. These assessments are expected to continue into fiscal year 2016. Dissolution of spent nuclear fuel is currently on hold, awaiting the resolution of equipment natural phenomenon hazard rating. And H Canyon continues to work on modifications to allow receipt of the Canadian liquid target residues materials. HB Line began processing plutonium again, yay, for feed material to MOX on August 3rd, so that's good news for us. They went through all of their recovery actions from the agitator event and were able to restart after a successful readiness assessment. K-Area continues destructive examinations of the 3013 plutonium containers to ensure the plutonium is safely stored and continues to...
Now attending.
John Richards, EPA.
K-Area also supports shipment of the 3013 containers to HB Line for processing. And then plutonium blend down capability for non-MOXable materials is being implemented in K-Area. Operations are anticipated to begin in late FY 2016. 235F has conducted a readiness assessment to allow replacement of the glove box components in preparation to begin those risk reduction activities. 235F, they're preparing to begin those activities right now. LRA has completed startup testing for the newly installed shielded transfer system, which will allow receipt of the Canadian NRU/NRX fuel. Facility self-assessment is completed, and the contractor's readiness assessment
Now departing.
hopefully start tomorrow morning.
John Richards, EPA.
So LRA continues to support fuel receipts from our foreign and our domestic research reactors, and we also support the fuel shipments to H Canyon. Any questions on that? Yes, David?
The spent fuel you're getting ready to process,
Yes.
which spent fuel is that?
It's our aluminum clad. It's the approved 1,000 bundles that we have from the amended record of decision.
Thank you.
Yes.
I never did go and look at the January 235F statement. When you're replacing those components, have you already put in the inner gas or
They're replacing the gloves and they've,
the atmosphere inside the cells themselves that cause the degradation of the current? Is there new argon in the cells?
I don't know if they've done that part yet. I don't think so.
Is that gonna be done when the new equipment's put in to keep it from degrading? Or you just think you're gonna use it quick enough that it's?
Yeah.
No, so you're just gonna use it quick enough to clean up and not give it time to degrade like the current ones are degraded?
Yeah, this first step is to clean the windows so that you can actually see what's inside and to clean the gloves. So that's the first phase that they're going through. So we're gonna take baby steps until they know.
Oh, the gloves, you're not doing the arms, the robotic arms,
They're replacing those as well.
those two? Okay.
Matt Barr, DOE. So Dawn, you're correct. We're going to replace the robotic arms, we call manipulators, that go from the clean side, the non-contaminated side of these hot cells. Hot cells are large enclosures where they did highly contaminated work inside these, shielded cells, shielded glass, and well contained. And so you remotely operated equipment inside these cells, and it was plutonium-238 that was used in the space missions. And so we haven't operated that facility for came in one Friday and
Now attending.
never resumed. So they literally just walked away way back then. And as Dawn said, and some of you are aware, over time, things have corroded. And so some of the manipulators, these robotic arms have corroded, so they're no longer used. And so part of it, in order to decon and remove that plutonium-238, it's essentially contamination is what it is. We need to restore some of that infrastructure that Maxine talked about, and part of that is replacing these robotic arms. When they operated, they had an inert atmosphere in these hot cells to prevent the degradation of materials and things of that nature. It's probably going to take us maybe 4 or 5 years to properly decontaminate these hot cells. And so we don't anticipate them degrading over that period of time. That's why we're not going to re-inert atmosphere or anything like that. We don't anticipate that these manipulators would degrade. And some of them, they even think they'll be able to repair and use again, and they may not even be able to replace it. So they've trained on both options. I can see your puzzle look.
Yeah, from what I've seen, yeah.
They do some minor repairs, and they may be able to get them operable. If they can't, they've trained and practiced on removing and replacing them. So to answer your question, no, we're not planning on reestablishing inert atmospheres in there.
J. Ray DOE, I think some of these cells have essentially 0 grams of PU-238. I think the most contaminated might have up to 20 on that side.
Yeah, on the.
Yeah, and so.
So you're doing the easy side, not the hard side.
We'll gain a lot.
Practice on the easy side.
We'll gain a lot of experience. Yeah.
Okay, because what I was thinking the other side where there's little piles of aluminum oxide from the degradation of the equipment, like big piles of aluminum oxide.
Those where we'd have to replace them.
Yeah, okay. Okay, that makes a difference, okay.
So the things that are corroded that you're having to throw away, is that stuff that would normally go to wet? Would be packaged up and go to wet, like they'll have to assess it. So if they can determine that it's low level waste and it meets our acceptance criteria for our disposal facility on site, then it'll be disposed on site. If it is in fact true waste, then yes, it will have to be packaged and meet the acceptance criteria for WIPP. But a lot of the waste that will come out of 235F will be true waste. Any other questions? Now I get to be out. Or try to be out. Alan had a vacation, right? I'm just talking about a pants cleaning. Definitely stuck with me. So I wanted to reacquaint you with H Canyon, tonight's an update on H Canyon area operations. So this is H Canyon. As you can see, it's a very large facility, over 1,000 feet long. I forget the width, so I'll be phoning a friend tonight for a lot of questions. You can see here the car, just to give you a concept of the size. And on the top, this piece up here is HB line. So when we talk plutonium, this is what we're talking up here. When we're talking spent fuel, this is H Canyon, the bottom section. There's about 4 levels in H Canyon and 2 levels in HB line. We didn't plan for that. So the purpose tonight is to fill one of your work plan activities. You wanted an update on what was going on in H area, so we wanted to do that. 2 of the main things is to tell you about our plutonium processing and also our spent fuel process. We've also included an update on the agitator event, because I think we promised that in a former CAB meeting. List of acronyms. If you have questions, please stop me. Here's your site map. This is H Canyon HB line. You can see it's the center of the site. We have a lot of ins and outs coming into this facility. It's our workforce. It's find in the country, so it's very unique. It's pretty much, there's only one other real facility that can do what H Canyon doesn't. So this year was again a busy year for H area. I like it when it's busy. So we continued processing spent nuclear fuel. We're in readiness assessments for the remainder of the uranium processing. So what we've done so far is we've dissolved the fuel. The fuel, remember, is those 3 to 10 foot long aluminum squares mostly. And inside is the uranium. So they've done the dissolving piece. There's other pieces that then we'll take and purify that uranium. So basically, it's separating the uranium from the aluminum and the fission products. All the fission products are going to go to the waste over in the tank farms, and that uranium is going to get purified, and then it'll get downblended, so it's no longer a proliferation concern. So it'll become low enriched uranium. That material will then be shipped to fuel processors so that it can be formed into fuel for the Tennessee Valley Authority reactors and be turned into commercial electricity. We talked about that. PU oxide production is beginning again. We're excited about that. This supports the NNSA mission of taking non-pit plutonium and turning it into a form that can be used in MOX. Turns it back into plutonium oxide. That meets their specifications. And then we are also going to talk about the agitator then. So, I'm going to slowly through this. So in 2011 is when NNSA decided that they were going to use HB line to help them with their mission to get MOXable plutonium ready for MOX. We have it stored in K area, so they decided that HB line and H Canyon, because there is a piece of the processing that has to be done in H Canyon. You'll see that on the next chart. So we had to do a lot of work. We had to make sure our DSA, which is our documented safety analysis, was up to par and could handle this process. We had to get additional staff that could handle the processing, and they had to go through and prove that all of this was ready. They had to do some reconfiguration in the facility as well. If I missed something, my phone of friends will correct me. Just so you can see. This is actually a picture of the canyon before they started operations. So this is back in the 50s. And we actually have cell covers that go over the top now. But this is, you can see that it's a very versatile facility that can be manipulated in any kind of direction we needed because of the piping. So it's able to do a lot of missions. They were very smart. So they both have. So for plutonium production, basically the 9975, you saw this container in Alan's slides last Tuesday. So it's that drum container that has a little inner can that's protected by the Celotex. So that's stored in K area. It gets shipped over to HB line, goes up to phase 3 of HB line, which is like a glove box section, and they have names for them. Gets unloaded. They get to that 3013. They actually have to unload the 3013 because remember it was a stainless steel can. The Canyon doesn't dissolve stainless steel. All of our units are made out of stainless steel, so we don't want to do that. So they have to repackage it into an aluminum can. So they do that in the phase 3 glove box. Once it's in a dissolvable can, then it goes down to a dissolver in the canyon. And remember, we have 2 dissolvers in H Canyon, one for spent fuel, one for plutonium. We do have capability for a third, but right now we don't have it installed. So the material gets dissolved, goes into a product tank, then the product tank goes up to be purified in HB line. This is the phase 2 glove box. So it gets purified basically through columns. You have a precipitate that's formed. That precipitate is then turned into an oxide, and that's the material that they need. So it gets packaged back up into a 3013, put into a 9975, and shipped back to K area, and now it's MOXable material that they can use. And then all of the waste materials either go back to the waste tanks here, or back to the waste tanks here, which goes back over to the high-level waste system. Fuel, where we're processing out and purifying the uranium, here they're processing and purifying the plutonium. Those blood balls, honestly, I don't know which phase it is when I tell you. Sorry. So they've completed all of the safety basis documentation. They've hired people, they continue to hire people. They've made the modifications that they needed to for the facility. We've completed readiness assessment, 2 times. They had to also do a readiness assessment after the agitator event, so they just concluded that and began operations again. So this was done last year. We're actually up to 8 cans now, I believe, to improve on their production rate, which we need to do to meet some of our mission requirements in. My favorite subject, spent fuel. So this is a loaded 70-ton cask. That's basically this with plastic over it. That means it has fuel in it and it's going to the canyon. That's a good picture. So we had the decision back in March of 2013 to allow us to process up to 1,000 bundle material test reactors with called aluminum clad research reactor fuel. They all mean the same thing. It's just whoever's given the presentation, it's their approval. So we have approval to do up to 1,000 bundles and up to 200 hypercores. Hyper, remember, is that circular fuel. It's a different shape. It doesn't go in the bundles. We actually have to change out the insert to the dissolver in the canyon in order to process that. So there are preps that we need to do for the hyper fuel that we haven't yet finished. So that's why you'll not see us talk about how much hyper we process, because we haven't processed any. We did initiate processing last September, and currently I think we've done 60 bundles as of the end of June this year. So it's a slow process, but we're making progress and we're going to get there. And as we talked about already, the material will go to Tennessee Valley Authority, and it'll be used for production of electricity. So it is a true recycling process. Also, with the 1,000 bundles and the 200 hypercores, we're projected to make about 40 metric tons of low enriched uranium, and that's what gets turned into the fuel. And from that, so from the processing of 1,000 bundles and 200 hypercores, we're going to generate approximately 35 glass canisters. So you can see it is a definitely volume reduction and recycling of material. Okay, we talked about the last bullet. We've heard a lot about Canadian liquids or liquid. This is Canadian target. We call it Canadian target material residue. The target residue material that goes back and forth. So this is material that was made when U.S. origin uranium targets were irradiated. They generate this target material. The material is used to generate Moly-99. Moly-99 is used for all of your medical isotopes. So Canada is our biggest supplier in the U.S. We currently don't have any suppliers in the U.S. There's a program to try and get suppliers in the U.S., but we don't have any right now. So the majority of our medical isotopes come from Canada. So they came to us as part of the Foreign Research Reactor Return Program, asking if they could return this material to us. It works out very well because it's basically already dissolved uranium fuel. So it can be fed into the H Canyon process after the dissolver and go concurrently with our fuel processing. So you use the same process that we use for fuel that we do for target. We just enter the canyon at a different location. This material management minimization program is the new name of the NNSA group. You may have heard them as Global Threat Reduction Initiative, called the MQ for short, Material Management and Minimization Program. The Canadians have about 6,000 gallons of this solution. They're going to send it down to us. We'll process it through H Canyon, purify the solution, discard the fission products to the tank farm, and this purified solution will then be downblended just the same as we would with our fuel. And then the processing of this liquid, because there's still aluminum with it, it's only going to generate about a glass, 1 canister of glass. So they're currently in prep to modify the canyon for the receipt of this material. It's going to be coming down in a special cask. You've probably heard of the LWT, the legal weight transport or legal weight truck. And that's what this is. It comes to like an ISO container. So it looks like an normal fueling that you would see at port. But inside, it's very specialized, and everything about this transport has been analyzed by the Nuclear Regulatory Commission. So what you see here, unfortunately, is the impact limiter. You can't really see the cask itself. It's behind that, and there's one of these on each end for accident scenarios, protects it. So what you have to do with a Type B cask is ensure that you're going to control and keep containment. You can't let the material out of the cask under any accident scenario. So that's what you have to go and prove to the NRC that your cask can do. So that's what's been done with this license application. Put it inside the cask, which the cask is what we typically receive foreign research reactor fuel in, but it comes in baskets with the fuel inside the basket. Because this is liquid, there's going to be 4 small canisters. I wish I had a picture of them, but they're going to be about this big, about 16 gallons is what they hold. And there's 4 in the container, and that's all that's going to be shipped at a time. So you'll have 1 cask full of these 4. But because of the radiation levels, you have to do this remotely. You can't just send somebody up, pull it out. So our folks in the lab and in the Canyon facility have worked out a way to have a mechanism to go in, remove this canister, put it into what we call a lead pig, and it's basically a bigger canister of lead to shield it, so that then it can be moved over, material pumped out, and put into the canyon. Sorry, let me take a drink. So once it's put into the canyon, it goes through our normal process. Everything's the same. It's pretty much just flow like we would normally flow. Then we have to make sure that these containers are flushed before we put them back into the LWT before they get sent back up to Canada to be refilled. So it's going to be a continuous process of these LWTs being moved back and forth between SRS and Canada. And Canada is the Canadian National Nuclear Laboratory Limited. It used to be AECL, which is Atomic Energy in Canada Limited. They've had a company change, so they have a new name. Because they're under IAEA, there will probably be IAEA tags on this material. And that's just basically, like at the gas pumps, you'll see them put a sticker over the mechanism for the charging, and that has a number on it. Same thing here. It's a tag with a number on it, that if it's been tampered with, you know something's happened. It just lets our security folks know, and their security folks know something's happened, we got to investigate. Typically, the tags are fine. We get them in L area a lot. You just make sure you verify it's the right tag, and you take it off and send it back to the shipper. Okay, agitator event. So back in early this calendar year, we had a loss of power incident, which caused us to lose power to some of our agitators and HV lines without us knowing. When it was identified, make sure I don't miss anything. So when it was identified, they went through the actions to figure out what happened, why, and what do we need to do to fix it. So they did find out that none of the physical limits were ever violated. So we never had a criticality potential. The safety base is credited thorough mixing of the material before it went down to the canyon. So we had to go back and verify what had been shipped down to the canyon didn't cause a problem. So you did sampling on that to get that information. Let's see. We talked about the loss of power. It had to do with the variable speed drives on the agitators. Those are what tripped off. And the operators basically were using a strip chart on a level to see that it was being agitated. And it was such a minute change that they couldn't tell that it had not been operating. So we had to come up with a new way of giving them an indicator of if it was operating or not operating. So they did install additional equipment, but I forgot what those were called.
Ammeters?
Yes.
That's part with DOE, so they installed independent ammeters, which basically determine and provide indication of the currents going to the motors that will turn the agitators. So it's a more objective means to determine that you actually have mixing within the tanks. We looked at putting cameras in there. Again, it's really not that accessible for uranium or anything else. And so, the equipment modifications they did put a positive indication based on current. Try those out, and if, you're not getting current, then you're not getting agitation, and therefore you would not proceed on.
So upon the discovery, operations were automatically suspended. The vessels were evaluated to ensure that we didn't exceed a criticality limit or that we had a potential to. They did an extended condition to ensure that all credited actions could be performed. And when we say credited actions, there are accident scenarios that are already identified in our documented safety analysis. So they go through and they do a hazard analysis in the beginning, and they postulate anything that could happen. And then they have to go in and see how they would mitigate that accident. So we have all of this in a document, and these documents are huge. We're talking 1,000-page documents that go through and analyze the accident to show what you're doing mitigates it and that it's safe to continue. So they went through that. Then they made the modifications that they needed to, so they had a positive indication. And then they were able to go through. So a readiness assessment is basically when you take, there's a bunch of forms, but we have basically 3 processes. One is the facility does one of themselves, and you go through and you look at your procedures. This is your people, your plant, and paper. People, plant, paper. You look at all those things. Are your people trained? Is your plant ready? And are your procedures in place? So they did that of themselves, and then they have what we call a contractor readiness assessment, which is where they bring in an independent team from the SRNS facility to look at the facility and ensure those 3 things are working. And then there's another level that's called a DOE. So once they've gone through the self-assessment, contractor's readiness assessment, there's a DOE self-assessment or readiness assessment that takes place. In this case, what DOE did was we did a shadowing. We shadowed what the contractor's readiness assessment was doing. So they were able to determine that the facility was ready. They had the people trained, they had the procedures ready, and they had the plant ready. So they were able to start operations, and they were able to begin again. This says July 20th. We have to put these in beforehand, so we were guessing on a date, and they did start up on Monday. So in summary, our facilities are operating. They are making progress, which is a good sign. H Canyon HB line remain a unique asset for our company and our ability to handle nuclear materials. We're continuing to dissolve the spent nuclear fuel. We're performing the readiness assessments to continue on that and purify the uranium. And they're continuing with their preps to receive the Canadian liquid. And we recovered from the agitator event. Yes, sir.
Maxine, you mentioned early on that some of the purified uranium was sent to a facility to prepare for fuel for production of electricity. Where is that facility?
It used to go to Oak Ridge, now it goes to Washington. James?
Hey, Ray, DOE. It used to go to Tennessee, but it's the Tennessee Valley Authority subcontractor called REBA that has built a plant and has a nuclear fuel service. And I don't think they've actually DC'd that, not yet, but
They moved their operation to Washington State.
thinking of moving, I don't think they totally moved it. They actually have an operating plant in Washington State, but they have built the one in Tennessee specifically to produce material. And I don't know that they've totally decided they're going to move away from Tennessee, but I'm maybe 95% confident that they will.
And that's transported by truck?
Yes, yeah.
It's an LR2.
They call it an LR-230. Each one holds nominally 230 gallons of LEU liquid.
So has any of the fuel that's been processed been shipped to TVA yet?
Not this round, no ma'am. Because all we've done is dissolve the fuel. We're waiting for those other lines to allow us to purify the uranium.
So it's being sitting waiting for purification.
That is waiting, yes.
But TVA is ready to receive when we're ready to ship?
We actually modified our contract with them. They're willing to take and ready to take on the extra 40 metric tons.
Dan Kaminsky, cab. On the agitators, if the agitators were to jam in there, is the metering sufficient that you're not going to get a false reading? Because it would still be drawing amperage.
I'm gonna let Pat answer that one.
Yeah, again, I'm not an electrical expert, but,
Nor am I, but
yeah.
I know it's
Somehow, it's configured that if it's jammed, I think, from what I understand, you probably get an overcurrent and probably some
I would hope so.
upstream breaker would trip, and so,
But
and
someone
the other
smarter
thing-
than us has thought through this and looked
yes,
at
and
all
the other
the
thing is,
FMEAs and all that good stuff.
yeah, there's two agitators in there. If one was to jam, really can't think of a mechanism that would cause two to jam or two to fail, and not know it. And so, so yeah, I think we've covered any foreseeable known failure mechanism, common mode failure or individual, and have that redundancy to ensure that, we won't have that problem again.
Thank you.
I have 3 questions, which I normally don't have, but, on page 6, with the documented safety analysis, what modeling is that?
So the contractor writes the report. I need to see it somewhere. With the documentation, the contractor prepares those. And then we have specially trained, engineers that are, assigned to specific facilities, and it's their job to go through those documents, and then they have to, prepare what's called a safety evaluation report. And that actually goes all the way up through our management, and Jack Craig will, once he's approved as a safety, manager, can sign off and approve the DSA. So right now, Terry Spears is serving that function and signing off on the, we call them SDR, safety evaluation reports.
And then on page 7, where you have H-Canyon and Dissolver, you said that you've got 2 for the spent fuel and then plutonium, but there's a capability for a 3rd?
You guys have different numbers.
Yeah, you have different numbers on ours, I'm sorry. Our numbers are
The
different.
Canyon can be configured for 3 dissolvers. Right now, it's only got 2. One is plutonium and one is for the fuel.
What can the 3rd one do?
The 3rd one, if it were put in, would do additional MTR fuel. It would just allow us to do more MTR fuel. We have to evaluate if that's gonna be a cost savings in the long run, because if the dissolver's not the, point, we may have another, operation down the line that may be the slow point, so it wouldn't make any sense to dissolve faster than you can, actually get rid of the waste or process the uranium so that it gets purified. So we have to evaluate that whole process.
The other question I have is, I always think about this and I've never asked, the truck drivers
Yes.
that do this, are they like DOE, truck drivers?
Or they are actually hired by the, shippers. They go through, especially if it's a type B shipment, which is what the liquids would be in all of our fuel shipments, they're hired by a special transport group. All of those are tracked through a Transcom system, so there's a database that's tracking them constantly, so you know where they are. But they do go through a clearance, not our kind of typical clearance process.
So if they went off the highway and they were missing for like an hour, somebody would know, okay.
Because when those shipments are in place, there's people that have to be at those Transcom monitors 24/7. There's a lot of security behind the scenes that no one knows about.
I always thought about that, and that would just be like the easiest step to look at all this other safety, and then you just have like 1 truck driver.
You know, there's a lot of things that we're not allowed to say that goes on, so it's very protected ship. Yes, David.
What was the date of the agitator event?
I believe it was identified in March. I don't know the actual date. I know that the loss of power was in late January, February. You know the date?
Yeah, J-Ray DOE, it was February, I want to say February 9th, but, September, I don't know. Yeah.
Thank you.
And just to clarify, we knew the power went out. What we didn't know is that the power came back and the lights came back on, the lights came on, drivers or whatever. Didn't realize that even though there was power to those, there was power to the agitators not there. So, I mean, we were aware the lights went out and all of that, but we didn't realize that everything was not reset.
How long were the lights out?
Several hours. It was a problem on a pole. One of the 2 lines came off, and, either hit the other line or hit the ground or something up there, but it was a failed,
Transformer, was it the transformer?
no, you're, yeah, the ground trap. It was the wire feeding the transformer, one of them fell against another wire. It was essentially the,
Thank you.
How much PU is in, after it's all purified and ready to go, and goes back to K area, that's ready to go to MOX, how much PU is in each one of those cans? Okay. I was like, I never remember hearing a number, now I know why. So, but given that that you know that number, but we don't know that number, and how much actually has to be processed to go to MOX eventually, hopefully, how long is that process, assuming you don't have power outages, and if you were just to be able to run, what's the plan anyway?
The plan right now, regardless of the amount, from what we are hearing from NNSA, they are wanting the process to go at least until 2023, 2024. So we're doing this for them, so they actually pay us money to process the plutonium.
And
So they're agreeing to do that, they're in their planning stages, they're agreeing to do that at least until 2023, 2024.
and that would process all of the MOXable PU that.
I don't know the answer to that. I know that's how much they're willing to put forward right now.
yeah, it would process all of the material that by processing through H2 lines and make oxidable material, J-radiated. But, and then of course you got two other categories, stuff directly done, and the stuff that has to go with the site.
Any other questions? Thank you, and sorry you had to listen to me all night.
Thank you, Maxine. Okay, thank you, Maxine. That was excellent. It answered a lot of questions. We have, I guess we could do committee discussion. Do we have any committee discussion?
Whatever Don Gillis got, I gotta remember to, crack the whip on me, because I always forget to do that. The recommendation that we did on the, cost of, or getting money from NNSA for shipping and processing spent fuel, what happened with that recommendation? Wasn't that one of ours? It happened like right when we first started.
I don't think that was nuclear materials.
Huh?
I don't think it was a nuclear materials recommendation.
The one that you and Jenny did?
Yeah. That wasn't a nuclear material, that was for spent fuel.
I thought that was strategic.
Oh, is it strategic, that's what came through? Yeah, I was gonna say it's nuclear material.
We responded and y'all adopted it in May.
Oh, I don't remember seeing that. How come I don't remember seeing that?
You weren't here.
Oh, is that when I was sick? No, so that would have been March. That would have been, I was in Savannah? I do not remember seeing that response.
Did you get meeting minutes, Savannah?
I was in Savannah.
They're
They're online, oh.
I was looking.
Well, they sent me the first one, so I assume they're gonna send me all of them.
I'm pulling it for you right now. Z19.
The response was, we'll try. I can't read it.
What was the recommendation number on that one?
330.
Okay, I see the part that says, without discouraging countries from returning the U.S. I wasn't intending to say we ask the countries to pay, but to ask NNSA. I have to read further down. Where was I? There, okay. I don't know if I agree. How come I don't remember seeing this? That is really weird. I would have been looking for, that second
Reading it.
have a lot of discussion on that part.
Well, if you, Maxine, I said, do an example of where we've worked with NNSA is, we need a new switchgear in L area. It's over 60 years old and it's way outdated. So we went to NNSA and told them about this need. So we are gonna 50-50 fund the replacement of the reliable power project, both in L and in K area, because they're both the same type of switchgear. So that activity is going on. We're working on procurement requests now that'll go out, and hopefully we'll get some vendors that can come in and we'll get it in the budget that we have. So that's an example of how we work with NNSA.
Versus getting directly money for the spent fuel, okay. Okay. Yeah, I know my glasses. Now it's not big enough I can read it. So that's the infrastructure piece you're talking about there.
You know, infrastructure is one of our highest priorities at the site right now, trying to get this done. And we have to use our WNO2 funds, the fuel fees, to do that where possible.
Okay, SRS has been successful in the, next page. Okay, the roads were funded from the fees, but the
Reliable power is not funded.
but I mean, it's like the running of Elk Basin in general to actually receive the fuel.
That's an EM activity, and that has, in the past, it was both EM and the WNO2 funds for the fuel fees run. That has changed. We put in place that the WNO2 funds were to be used for infrastructure projects that were approved by Pat McGuire or JJ Hines, or in extreme cases, operational offset. So that did change. So all of the money right now is targeted for WNO2 for infrastructure projects.
So EM is fully funding the operations of.
We have to evaluate on a year-by-year basis, and so
Nothing's changed there.
that's our goal.
And there's a habit in the back of the room.
We wonder why we can't afford to go to other places. Okay. I must have been asleep.
Is there ever an issue where outside agencies need something to get done, they don't have the funding, and SRS doesn't have the funding? Is this a constant battle of dollars?
We fight budget, Maxine, we do fight budget scenarios a lot. Typically, if there's a high enough priority on a mission, the department will find the money in some way.
Okay, any other committee discussion? That's all we've got. Public comment, okay.
Do we want to brainstorm before we sign off, or?
Anybody in the public have comments on anything that you've heard?
Any ideas?
Just complaining about weekdays and 9 to 5 hours.
So, I guess, we'll adjourn.